in the last 3 weeks, we have studied the C programming language, the embedded C programming language. From this week, we will be studying the microcontroller. We have studied C programming because you have to program a microcontroller before you want an operation from it. So, to program a microcontroller, you will need C language. But now we will learn about the basic microcontroller structure, or how we can program it and how to program it. There are many types of microcontroller, but the microcontroller we will be studying in this course, this is Atmega 32. So in Atmega 32, if you want to look at the schematic diagram of Atmega 32, this is the schematic diagram of Atmega 32. So in a microcontroller, there can be many ports, many pins. In a Atmega 32 microcontroller, there are mainly 4 ports. Okay, so what are the ports? We will study it later. So there will be main 4 ports. They are port A, port B, port C and port D. And in each port, there will be 8 pins. So if you look at this schematic chip or IC, then you can see that this is the port A. There are 8 pins of port A. This is port C. There are 8 pins of port C. These 8 pins are for port B and these are for port D. So for each and every port, there will be 8 pins, and the pins will be denoted from 0 to 7. They can be denoted from 1 to 8, but it's a basic convention to specify these pins from 0 to 7. So if you want to access the first pin of port A, you will denote it by port A 0. Then the second pin will be port A 1, and similarly sequentially you will get the last pin of port A by writing port A7. So port A7 can also be written as PA7 in short. So if you want to access the say 7th pin of port B, 7th pin means in this convention it will be 6. So we will write port B6, or in short we can write it PB6. Okay, so if you look closely, then you will find there are 8 pins in each port, PB0 to PB7. There are the 8 pins of port B. Here are PD0 to PD6, but in this schematic diagram, PD6 pin is here and PD7 pin is there. You can find it, PD7 is here, but when you will use a hardware of microcontroller, then you will see that all the pins are at one side. Okay, so then this is PC0 to PC7, that's 8 pins of port C, and here are PA0 to PA7, so the 8 pins of port A. So in each port there will be 8 lines or 8 pins, and each of this line or pin can be used as input or output. So there is no strict rule or restriction on which pin you can use as input or which pin you can use as output. You can use all the pins as input or output, but at a single time you can use one pin as either input or output. That means you cannot say you are writing a code, and for a particular time or for a particular operation, that pin will be only input. You cannot use that pin as input or output at the same time. So this is the convention. And what do I mean by input or output basically? So I have already said that you have to program the microcontroller. The microcontroller is just a chip. It has got many operations in it. It can do many works at a time, but first you have to program it. So you have to give it the order, what it will do, or what tasks it has. So if you want to program a microcontroller, then you have to write a code, and that in that code you will have to write what the microcontroller will be doing for a particular time or for a particular day. So in that code you have to declare a port as an input or as an output. Now what do I mean by declaring input or output? That means say you will give some instruction to port A from your code. Okay, so your code will give instruction to port A. In this time the portway is acting as output. That means it is getting the instruction from code, and then it is following the instruction and doing some task. So port A is getting its instruction from the code and it is working as output. Okay, and this is the output mode, and in many code what we will do, we will connect the microcontroller port to a particular peripheral device. For example, it can be a keypad, it can be a switch. So in input mode, we will not give the instruction to this pin or to this port from a code. In the input mode, if you connect a port or a pin to a peripheral device, then the microcontroller's port or pin which is connected to a peripheral device will get the instruction from that peripheral device, and it will pass the instruction to that to your code. Okay, so in this time the port or the pin is working as an input port or input pin. So in an input mode, the port or pin is getting instruction from a peripheral device, and then it is passing the instruction or passing the data to your code. So in this case, it is working as an input pin or input port. So you can declare any port, any pin as input or output, but this declaration is for only one time. So you cannot use a port or a pin input and output at the same time. Okay, so when you are writing a code, before you are starting your code, you have to declare your a pin as input or output. So before you are starting to give any kind of instruction, before you are sending any data or before you are receiving any data, you have to declare a port as input or output. So how to do this task? That means how I can declare a port as input or output. There are some specific lines, some specific instruction using which I can declare a port as input or as output. We will be using a register called DDR to declare a port as input or output. So this is written here, the functions and the way you will declare a port as input or output. The full form of DDR is data direction register. So this register will be used for the purpose of making a given port input or output port. So for making port A as input or output, or for declaring port A as input or output, we will use DDR-A. For port B, you will use DDR-B, then for port C, DDR-C, and for port D, DDR-D. Now, using this register, we will declare a port as input or output, but how we can do that? So there is a particular convention, or there is a particular set of code that we must write beside this DDR-A or DDR-B to declare a port as input or output. So what is this? For example, I'm drawing it here. For example, this is a microcontroller, and I will use this microcontroller to carry out some function using only port A. So I'm dealing with port A here. So let's say there are 8 pins of port A. So these are the 1, 2, 3, 4, 5, 6, 7, 8. Okay. So this is PA0, this is PA1, this is PA2, and so on. And this is PA6, and this is PA7. All right. Now I want to declare all the pins of port A as the output port. All right. So there are 8 pins in port A. So I want to declare all the pins of port A as output port. So if you want to declare a pin as output port, then you have to send a 1 to the register for that pin. That means for PA0, you will send a 1 here if you want to set it as output. And if you want to set it as input, then you have to send a 0. So if you write a 1 to data direction register, then it will be declared as output, and if you want to declare as an input, you have to write 0 in the data direction register. All right. So now if I want that, I will declare all the pins of port A as output pin, then I will send 1 to all of these pins in data direction register. So in data direction register, I will write, say I am writing a binary code here, then I have to start it using 0B. Then there will be 8 slots for the 8 pins. The rightmost slot is called the LSB, and the leftmost slot is called the MSB or most significant bit. So I will send 8 ones to all these pins. This one is for PA0, this is for PA1, and similarly it goes on, and then this is for PA7. So if I write 1 for all the pins of port A to this data direction register A, then automatically the microcontroller or the program or the compiler will understand that port A has been declared as the output port. Now, if I want to write it as an hexadecimal number, not as a binary number, then I have to start it with 0x. Then for this 41 means F, and this 41 means F. So if you write DDRA is equal to 0xFF, then it will also declare the port A as output. So you can write it or you can write it, whatever you prefer. And now if you want to declare port A as input pin, then similarly you will have to send 0 to all the pins of port A. Then I will write DDRA is equal to 0 binary, then there will be 8 zeros. Okay, there will be 8 zeros, or 80 and 10, they are all the similar things. So you can just write 0, or even you can just write 0, because decimal 0, binary 0, hexadecimal 0, they are all the same thing. So you can just write 0. Now there is also one function that you do not have to declare all the pins output or all the pins input. You can divide them. That means you can declare some pins of a port as output, you can declare some other pins of the port as input. So how can I do it? So for example, I am writing a code where I want the first 4 pins, that means PA0 to PA3 as the output pin, and then from PA4 to PA7 as input pin. Alright, then what will be the code that is sent to data direction register? This will be, say I am writing binary here because when you are making or declaring a port as input or output, I am sending 0 or 1, so it is easier to write the binary numbers. So this is 0B, then let us say I am writing from LSB. So LSB is PA0. So PA0, PA1, PA2 and PA3, they will be output. So there will be 1. This one is for PA0, then it is for PA1, this is for PA2, this is for PA3. So these ones are sent to the first 4 pins of data direction register A. That means by this 4-1, I am declaring the first 4 pins of port A as the output port. Now there are some other 4 pins and I wanted to declare them as input. Then I will write 4-0. This 0 is for PA4, this is PA5, this is PA6 and this is PA7. Now if you write it in hexadecimal mode, then it will be 0x0f. Okay, so by this data direction register you can declare a port as input or output, and also you can divide them. So I have written the code for port A, but the similar thing will be also applicable for port B, C and D. You can similarly declare port B, C, D as input or output, but you have to keep one thing in mind, that whenever you are writing a code, before starting writing the code, you must declare the ports as input or output. Say you are writing a code where you will be using port A and port C, then before you are writing your main code, you must declare this data direction register for port A and C. So before you are starting your code, you have to write DDRA and DDRC, and you have to send 0 or 1 to the particular pins, and you have to declare the pins or the ports as input or output before any code starts running.